Hi everybody, here is the second half of yesterday's notes. So for my algebra loving folks, you are really gonna love today. Today is all about algebra details. Like that's all it is, super high algebra details. Okay, so let's go through the whole thing. Have your graphing calculator ready. Let's do it. Okay, so what are all the complex roots of the polynomials? So first of all, I know that there's going to be 4 of them per the fundamental theorem of algebra. Now it says list the factors because we're heading toward that P over Q thing. All right, so first thing I'm going to do is P. P is -2, so its factors are plus or minus 1, plus or minus 2. Then we have Q. And notice I'm stacking them on top of each other. Again, that's just a little helpful reminder for me. +3, plus or minus 1, plus or minus 3. All right, so now we list all possible. That's P over Q. Q. Plus or minus. All right, remember, methodical. 1 over 1, 1 over 3. 2 over 1, 2 over 3. So 2 over 1, of course, is 2, and 2 over 3 is 2/3. All right, so again, I don't expect you to come up with the test on your own or know what to test. At this point, it says to test to see if this and this are roots, and it says use long division. Then it's going to have me do this way. Now, one of the things I showed you today is how to turn this into this. So just a little quick reminder, if we have x equals 2/3, we're going to multiply the 3 to the other side. Then we're going to subtract the 2. So that's where they're getting that factor from. Now, remember, I showed you today, you have the option of doing long division or you can do it the shorter way. So I am going to do the shorter way. I'm going to do synthetic division. Yes, I know it has a fraction. I'll also show you the other one. When I get to the other one, if you're fine with synthetic, you can stick with synthetic only. But if you prefer to see the other long division, that's fine too. All right, I'm going to put my coefficients down. Bring your 3 straight down. 2/3 times 3. That is going to give me 2. Add, I've got 6. 2/3 times 6, that's 4. Add straight down. 2/3 times 6, I've already done that, that's 4. Add straight down. 2/3 times 3 is 2. I end up with a 0. My depressed polynomial is 3x cubed plus 6x plus 6x squared plus 6x plus 3. So that's my depressed polynomial. Now it wants me to divide by this one. So I'm going to take x plus 1, set it equal to 0. So x equals -1. So that would give me, if I'm doing, again, synthetic division, -1. You're going to take your depressed polynomial and continue on down. So you've got the 3, -3, add straight down. -3, add straight down, -3, add straight down. So now my depressed polynomial is 3x squared plus 3x plus 3. Now, step number 4 is going to be to do the quadratic formula. And if you want to skip ahead so you don't need to see the long division, I totally get you. But over here, I'm going to do the long division for my long division fans. So I've got my long division all set up over here. And again, if you want to skip ahead, you just do that. Please remember that if you're missing any terms, make sure you put in a 0. I don't have any here, so I don't have to worry about that. Okay, so your goal with long division is to get the front pieces to match for both of these terms. Looks like I'm going to need an x cubed. So I'm going to multiply by x cubed times this binomial on the outside. So I get 3x to the 4th minus 2x cubed. Okay, here's the hard part about long division. You have to subtract. So the first term, easy, that's gone. Here's where it gets hard. It's 4 minus -2. That gives you 6x cubed. Now, that's a binomial, so I'm going to bring down a 2x squared. Now, I need these to match, so I'm going to use 2x squared. So I'm going to put that 2x squared right there. And then I'm going to multiply that times both of these terms, giving me 6x cubed minus 4x squared. Again, hard part about this is remembering to subtract. You don't have those issues with synthetic division just because you're always adding. 6 minus 6, easy, that's gone. 2 minus -4 is 6x squared. Again, I'm going to bring down a term. I want these two to match, so I'll use 2x. And then you multiply it, so you get 6x squared minus 4x. Remember, here's the hard part. You got to subtract. Those go away. -1 minus -4, that's going to give me 3x. And then I'm going to bring that 2 down, or the -2 down. And those already match. So all I have to do is multiply by 1. So you will notice that you basically get the same thing as here. Now you may be saying, but those don't match. That's because this isn't factored. You notice it's got a 3 in all of those. So we're going to sort that 3 out later, but you'll notice you get the same thing here. And of course we get no remainder, just like we had here. But again, same thing, just has the 3 divided out of it. Notice down here, you could take that 3 out as well. As a matter of fact, I plan on doing that right now. Okay, so the last thing is use quadratic formula to find the roots of the quadratic factor. That's the quadratic factor right there. Now, what if you did it with a 3 in? It's just going to make your numbers a little bit bigger. So let's do the quadratic formula. So opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so cleaning that up, that's -1 plus or minus the square root of -3 over 2. So that's -1 plus or minus I square roots of 3 over 2. Okay, so my fundamental theorem of algebra says that there are 4 roots. Let's find our 4 roots. So first of all, back up here, I have the 2/3. I also have the -1. And now I've got my 2 imaginary roots. So 1, 2, 3, 4. And I have completed my problem. So 1, 2, 3, 4. All I did was write them down here. Now my suggestion for you as a student is as you go along, circle your answers. And that way, when you get to the bottom of your paper, you have absolutely circled all your answers. They're easy for me as your teacher to find and grade. Everything looks fantastic. All right, let's flip over to the next page and let's take a look at problem 3. And then we'll work backwards a little bit. Again, all my algebra lovers, you're just going to love this today. All right, so first things first on this particular problem, it says, what are all the complex roots? So anytime I give you a problem, first thing, if I haven't specifically said for you to use a graphing calculator, you of course can, but I also want to point out to you that your first option, whenever you have 4 terms, see if it'll factor by grouping. You know, if it'll factor, that's way faster than you digging out your calculator. So if I go in to factor this, I'm going to get an x squared out of this first pair. Then I've got x minus 2. Second pair, I've got a 5 I can get out. That leaves me the x minus 2. So I have x minus 2 and x squared plus 5 equals 0. So I'm just going to set my factors equal to 0. This one's really straightforward. I've got a 2 here. Circle it, of course. Don't miss an opportunity to circle a root. Then this one doesn't have an x squared on it, so an x to the first power, so I don't need to do quadratic formula. I could, but I don't have to. So notice I'm just simplifying it down. So let's take a look. I was supposed to have 3 answers, so that's 1, 2, 3. Now again, you could have found the 2 with the calculator, and then you could have done synthetic division. If you look at the key that's posted online, that's what was done. But always check for something simple like factoring. All right, so now it's time for us to do the reverse. This is called the conjugate root theorem. So what you have to do on these is it requires you to know 2 different things. First of all, remember I told you back when we did the fundamental theorem of algebra that you always get a pair of imaginary roots. Now the problem with that is you're not always told explicitly in the problem what the second root is. And I think to myself, why? Why are they trying to cheat you that way? But that's just the way these problems are written. So if we look at this problem, it says write a quadratic function p with rational coefficients such that p of x has this and only this is a root. Now you, as a student, just have to automatically in your mind know that if it has this for a root, it also has this for a root. It is a trick. Yeah, that's right, a trick. A trick that you as a student just have to know and be looking for, because you know that your imaginary roots always come in pairs. Now, when you're doing this, make sure that you don't change both signs. You only change the sign in front of the imaginary piece. Okay, so we've got our 2 roots. Here comes our fun algebra part. So you're going to write p of x. Then, and I know it's going to be a lot of parentheses, but you're going to be fine. You're going to write x minus the first root. Then you're going to write x minus the second root. So it's always x minus whatever answer they give you, x minus whatever answer they give you. Now at this point, here comes your fun algebra. Distribute your negative. Distribute your negative. So you've got your roots there. At this point, we have to multiply them out. Now, I like to use a box, but if you just want to do FOIL, you just do FOIL. Here comes my box over here on the side. So let's do the box right here. Now you may be saying, why are you making such a big box? Because there's 3 terms on each side. Make sure you take your signs with your terms. So here we go. We're going to do those pieces. All right, so again, why am I doing a box? It just helps me be more organized when I'm working my problem. So x times x is x squared minus 2x minus, now here you go. You can put these 3 terms in any order you want, but most of us either like to write it this way or you like the x in front of the I. It's really your choice though. So then you've got minus 2x plus 4. Then you've got 10i. Then you've got, again, you've got to deal with that x situation. I'm just going to put it at the end. And then here's where you get a little bit tricky. You have to remember that I squared is -1. So that's negative 25i squared, which makes that positive 25. Remember, I squared is -1. All right, so let's take a look at what we can get rid of. I can get rid of this piece and this piece and this piece and this piece. So that means that when I come over here to rewrite my polynomial, I'm going to have x squared. I'm going to put these 2 guys together right there. Then I've got to put the 4 and the 25 together. And that is what my polynomial turns into. So it's just a lot of multiplying and combining like terms. Nothing super hard. You just have to remember that double root situation. All right, let's do another one. Flip over to the other side. Okay, so we know our polynomial has degree 4. Let's go find our roots. So here's one root, and there's the other root. Okay, let's make our imaginary roots that go with it. So remember that you also have 3 plus the square root of 7. Now you may be saying, whoa, wait a minute. That doesn't have an I in it. Why are you doubling it? Well, with our irrational roots, which square root of 7 certainly is, it also has an opposite pair. And then we also get a negative 4i. All right, put on your ready to do algebra gear. Let's go. So this is function q. By the way, I'm not going to take off if you use the wrong function name out here. My goal is your algebra skills. All right, so I've got x minus, and you're going to use parentheses because you're going to have to distribute. All right, and close that one up, and then you get x minus 3 plus the square root of 7. Then you've got x plus, minus 4i. And then you've got x minus negative 4i. And that is all my pieces. Wow, that is an awful lot of stuff to be multiplying together. All right, so as far as things go, these are probably your easiest ones. Those are going to be your uglies right there. They're not terrible, but they aren't nice. Okay, so let's kind of clean things up a little bit. Let's distribute those negatives. So you've got x minus 3 plus the square root of 7. You've got x minus 3 minus the square root of 7. Over here, I've got x minus 4i, and I've got x plus 4i. Okay. All right. So now it's time to start doing a whole bunch of math. So, like I said, I like doing the boxes, so I'm going to do the boxes, and then I'm going to put it all together down here. But let's get our box set up. Okay, so I've got x minus 3 and a positive square root of 7. And I've got x, let's see here, minus 3. And then I've got a negative square root of 7. And I'm just going to go through and I'm just going to do that math. So that's x squared minus 3x. That will be x square root of 7, or 7 square roots of x, whichever way you want to do it, minus 3x plus 9 minus 3 square roots of 7. Then you got negative x square root of 7. Then you got 3 square roots of 7. And then finally, you're going to multiply square root of 7 times square root of 7. That's square root of 49, which is 7. Now let's get rid of our extra pieces. So out of this, we end up with x squared, looks like minus 6x. And then we're going to add those two pieces together. And that gives us, oh, sorry about that. That's a sign error right there. That gives us plus 2. Okay, now let's go do the box for the other one. A lot of boxes on this one. So some of you have already figured out what this one is, but again, that's why we do the algebra, just so we have all the pieces together. Okay, minus 4ix plus 4ix. Then we've got, we're going to multiply those together. So that's negative 16i squared, which you know turns into 16. So that becomes x squared plus 16. All right, last step, you got to multiply those together. You got a lot of FOIL to do. Again, I'm going to come over here. I'm going to make one more box. I know it feels like all we're doing is multiplying, but you know, in a way, this is kind of enjoyable. I know you're like, what? Yes, kind of enjoyable. So I've got x to the fourth minus 6x cubed, 2x, 16x squared. Ooh, so much. Oh, that's a square on there. Whoops, I almost forgot that. I know somebody would have said something. Somebody out there would have been like, oh, no, Miss Blayford, you forgot that. Negative 96x and a 32. All right, time to put it all together. So my final answer is x to the fourth minus 6x cubed plus 18x squared minus 96x plus 32. Wow, that was a lot of algebra. Notice that we ended up with something with degree 4. Well, there you go. That's what that looks like. Now, I'm going to work through one more of these with you, this last one, but this is really similar to one on a previous page. So if you feel like you don't need it, that's perfectly okay. But if you want to see it, that's what I'm here for. So it says write a quadratic function with rational coefficients. Okay, we want me to go back to P of X. Now, what I want to remind you of is, remember, you get that negative. So you're going to have x minus 5 plus 4i and x minus 5 minus 4i. Let's do some distributing. Remember that negative goes to both. And distribute. Okay, now it's time for you to work this one out. Do the FOIL on it. Me personally, I'm going to go ahead and I'm going to make the box. Some of you knew that was coming already. However you'd like to do it. I just like the box because it's very organized. Okay, so I've got x squared minus 5x minus 4ix minus 5x plus 25. Then I've got 20i, 4ix minus 20i. And then over here, that's negative 16i squared, which turns to a plus 16. Because remember, I squared is negative 1. All right, let's cross out the extra stuff. So I end up with x squared minus 10x. And I'm going to add the 25 and the 16 together. And that's my answer. That's my polynomial. It's a quadratic function that meets the criteria. Okay, that's everything for this section. We'll do our last unit. What you need to make sure you're practicing is, of course, the homework. But in addition to the homework, start looking back on those skills that we have been working on. Stuff like long division, synthetic division. Are you good at solving quadratics? Do you need extra practice with factoring? Don't forget that on Monday, Ms. Holbrook has a review. You can come and see her for extra help and review. On Wednesday, you can come and see me for extra help and review, and I'd be happy to help you. And then our test will be coming up shortly thereafter, which means, of course, we'll have a review really soon. I hope you all have a really good day. If you have questions, you can email me those questions. When you email me and say I have a question, and then send me a picture of what the problem is. That way I can work it out for you and send you back some information. And again, on Monday, if you have questions, I would love to answer those. Just write down what problems you need to see. And I hope you all have a very good weekend.